Assalamualaikum warahmatullahi wabarakatuh. Now we will move to the first application of redox reactions, which is conversion of iron 2 ion to iron 3 ions and vice versa. For your information, compound of iron 2 ion, which is Fe2+, and iron 3 ion, which is Fe3+, are widely used in our life. One of the usage is iron pills, which contain iron 2 gluconate, or also known as ferrous fumarate, used to treat anemia, which is lack of red blood cells, and for pregnant women. So for your information, red blood cell is very important in transporting oxygens in our body. Iron 2 ion is green in color. When iron 2 ion change to iron 3 ions, it will release electrons. Therefore, iron 2 ion undergoes oxidation. It makes iron 2 ion act as a reducing agent. If you see in the diagram, the pale green iron 2 ion will change to brown because the product of the reaction is iron 3 ion. On the other hand, the iron 3 ion, as I said before, the color is brown. During the reactions, iron 3 ions will receive electrons to form iron 2 ion. Okay, the reactions is vice versa. Okay, when iron 3 ion receive electron, it will undergoes reduction reaction that makes iron 3 ion as an oxidizing agent. But these two reactions cannot be done simultaneously. We need the agent to help iron 2 ion change to iron 3, okay, and iron 3 change to iron 2. Before we go to the reactions, I need all of you to memorize again what we have learned in topic salts. In salts, we have learned to confirm the presence of iron 2 ion and iron 3 ion. We used sodium hydroxide solution and ammonia solution. If you remember, when iron 2 ion is added with small amount of a few drops of sodium hydroxide solution, it will produce dirty green precipitate. When sodium hydroxide is added in excess, the green precipitate insoluble in the excess sodium hydroxide solution. These observations is same when we add ammonia solution into the test tube containing iron 2 ion. While for the iron 3 ion, when sodium hydroxide solution is added into the iron 3 solution, it will produce brown precipitate. The brown precipitate insoluble in excess sodium hydroxide solution. The observation is also the same when we add the ammonia solution into the test tube containing iron 3 ion solution. So you have to remember how to identify these both ions because we will use it to identify the ion during the redox reaction. In this slide, we will see the experiment on how to convert iron 2 ion to iron 3 ion. First, we have to pour 2 cm³ of 0.5 mole per decimeter cube of iron 2 sulfate solution, which is freshly prepared, into a boiling tube held by a boiling tube holder as shown in figure 1.5. As you can see, the color of iron 2 sulfate solution is pale green. That shows the presence of iron 2 ion. Using the dropper, we have to add bromine water while shaking the boiling tube until no further change can be observed. After that, we need to gently heat the mixture in the boiling tube. As we can see, the pale green solution will change to brown. It shows that iron 2 ion has released electron and formed iron 3 ions. Iron 2 ion undergoes oxidation. Therefore, iron 2 ion is a reducing agent. While what happened to the bromine water? Bromine water will receive the electron released by iron 2 ion earlier and undergoes reduction reaction. We say that bromine molecule is an oxidizing agent. Okay, what do we have to do to confirm the presence of iron 3 ion? We need to add sodium hydroxide solution into the mixture to confirm the presence of iron 3 ion. Then we have to record all observations. What happens when we add the sodium hydroxide solution? The brown precipitate will form. Confirm the presence of iron 3 ions. Next, we have to form an ionic equation. In order to form the ionic equation, we need to write the half equation first. This is the oxidation half equation, where iron 2 ion release electron to form iron 3 ions, while the reduction half equation shows that bromine molecule receive 2 electrons to form 2 bromide ion. In order to form full ionic equation, we need to ensure that the quantity of the electron is the same. If we look at the electron in the oxidation half equation, there are 1 electron that has been released, while in the reduction half equation, there are 2 electrons that need to be received by bromine molecule. In order to make the electrons equals, we have to times with 2 the oxidation half equation, so that later on we can cancel out the electron. After we have times with 2 the oxidation half equation will becomes like this. 2 electron plus iron 3 ions. Okay, 2. So when the electrons are the same, one of the electron before the arrow and one electron after the arrow, we can cancel out the electron. After that, just write the remaining reactants and product and becomes the full ionic equation. Now, we will see the experiment on how to convert iron 3 ion to iron 2 ion. In this experiment, we need to pour 2 cm³ of 0.5 mole per decimeter cube of iron 3 chloride solution, which contains the iron 3 ions, into a boiling tube as shown in figure 1.6. Okay, as you can see, the color of this solution, iron 3 chloride solution, is brown. We have to add a spatula of zinc powder into the solution in order to change the iron 3 ion to iron 2 ion solution. Okay, before that, we need to gently heat the mixture and then filter the mixture to remove the excess zinc powder. Now, the iron 3 ion, the brown solution, has changed to pale green. Okay, this indicates the reaction has occurred. What are the reactions that occur? We know that the zinc powder, which contains zinc atom, has released electron to form zinc ion. Zinc atom undergoes oxidation. Zinc atom are said to be a reducing agent. On the other hand, the iron 3 ion, which is the brown solution, have received the electron to form iron 2 ion. Iron 3 ion are said to undergo reduction reaction, and it is also an oxidizing agent. How to ensure that the green solution consists of iron 2 ion? We need to add sodium hydroxide solution into the filtrate to confirm the presence of iron 2 ion and then record all observation. Now, let us look what happens when we add sodium hydroxide solution. The dirty green precipitate form. This green precipitate is insoluble in excess sodium hydroxide solution. This confirms the presence of iron 2 ion. Now we know that the first iron 3 ion has changed to iron 2 ion. Next, we need to write the full ionic equation for the reaction occur. In order to write the ionic equation, we need to have the oxidation half equation, where zinc atom release 2 electrons to form zinc ion. And the second half equation is for the reduction reaction, where iron 3 ions receive electron to form iron 2 ion. as we look at the example earlier, we need to make sure that the number of electrons or quantity of electrons are the same. The reduction half equation have 1 electron, while the oxidation half equation has 2 electrons. We need to multiply the reduction half equation with 2 in order to make the electrons the same quantity. Therefore, we will have the reduction half equation multiplied by 2 to form the new equation. Please note that the multiply version is only to equal the number of electrons. The half equation is still this one. Okay, so we need to cancel the electron and write the remaining reactant, which is zinc atom here, and 2 iron 3 ions here, and then the arrow to produce zinc 2 plus ion and 2 Fe2 plus ion. Okay, so this is the complete ionic equation for the reaction of conversion iron 3 to iron 2 ion.